Let's take a look at lesson 79 together. We're going to be talking about systems of equations with subscripted variables. If you recall with me, back in lesson 71, we were introduced to subscripted variables such as the number of nickels. Remember I told you that n sub n is going to end up eventually representing the amount of nickels, and we saw the number of dimes, or n sub d. We solved some problems using those subscripted variables. That is a subscripted variable, sub because it's at the bottom. And I just lost my page. Let me pull that back up. There we go. So sub means bottom or underneath, right? So a subscripted variable is going to be a variable with a little subscript underneath. Okay, so I'm going to start off with a little example here of something we're going to be looking at today. Our subscripted variables are going to be a little bit more confusing. They're not complicated, but they're going to be a little confusing because you're going to have to keep up on lots of different looking ones. So we're going to have several in this one: r sub a, t sub a, r sub p, and t sub p. Okay, so I'm going to write down some of this given information that I'm going to lay out here, and we're going to solve here in a moment for r sub a. So let's get some values for some of these variables. Remember, a variable is just representing an unknown number. Now in this case, some of our variables have known numbers. Look at rp. R sub p is 50. T sub p is 4 and t sub a is 3. But over here we have this equation that's set equal to 320. We want to solve for r sub a. Well, the only place that I see r sub a is right here. Okay, so this is the equation we're going to start with. R sub a times t sub a plus r sub p, t sub p equals 320. And we're simply going to fill in values of those other variables. So we're solving for r sub a, so we're going to leave that one as it is. We don't know that value. But t sub a is 3, r sub p is 50, t sub p is 4, and all of that is supposed to equal 320. So let's do a little bit of math here. I'm just going to move this 3 over to the left, so it's the coefficient of the variable, plus 200 equals 320. And we'll subtract this from both sides. 120 divided by 3. And r sub a will equal 40. Okay? You see how we did that? So we took the original, the first equation they gave us, where you can see RA is represented in there with no value though, because that's what we're solving for. So we use that as our beginning point, the first equation, and then we just take the other values and substitute those in. All right, we're going to do another one, but we're going to do one together. So in your notes, look at lesson 79, and right below your practice squares there, we're going to actually do one together here. We're going to do a little story about a turtle and a rabbit. So I want you just to put right here, example 1. And right beside it, just put a turtle and the rabbit. Okay, so that's what our example is going to be about here. And the reason we want to do that is because I want to show you how we can write subscripted variables to represent certain things in a word problem. So let's say this was a word problem about a turtle and a rabbit traveling a certain length of time at a certain rate of speed. And we know that if we multiply rate times time, we always get distance, right? So we know when we think rate and time, we know we're solving for distance. But in this case, we're going to be looking to solve for the time that it takes this rabbit and this turtle to travel. Okay, so I'm going to write down a couple of things that we want to just establish right away. So let's say that we're going to refer to the rate of the rabbit as r sub r. And we're going to write here that that is the rate of the rabbit. And then the time of the rabbit could be t sub r. Okay, so the small little subscript represents the who, or what, and the larger variable there stands for what it is that what's the mathematical part of this equation or this item. So the rate of the rabbit and the time of the rabbit. And then also, put a little line underneath that, we're going to represent R sub t, we're going to represent the turtle, the rate of the turtle. And then, of course, t sub t would be the time of the turtle. And I want you to write that so you can remember how we came up with those subscripted variables. Now we're going to solve, put a little line under here. Here's our instructions. Right here. Solve for the time of the rabbit and the time of the turtle. So we're solving for time. Now, we're given some information. Let's write this down. So we're told that the rate of the turtle times the time of the turtle, which would be the distance, by the way, plus 120. Now, this is given to us. This isn't something that we solved for. If you're sitting there thinking like, well, how would I know that? You know that because the problem would give you that information. Now, they also give you the information that the rate of the turtle is 2. The rate of the rabbit is 10. And the time of the turtle is the same time of the rabbit. So they're traveling the same amount of time at different rates of speed. Okay, so we want to solve for the time of the rabbit and the time of the turtle. Now take note. What does that last thing over here say? It's the same time. So the turtle's time and the rabbit's time will be the same. So if we solve for one, we will know the other. So let's use this equation and plug in our parts here. So I'm not going to rewrite that part. I'm just going to leave it as it is, and I'm going to substitute in for RT. RT is 2. The time of the turtle is TR, right? And I grabbed that from what's boxed in over there in orange, plus 120. The rate of the rabbit is 10. The time of the rabbit is TR, which is already here. We're going to leave that as is. And the reason I don't want to put the time, I don't want to change this to T sub T is because I want one variable in my equation. So I'm going to go ahead and leave this TR on the end as is. But now I have something to solve. So let's move using algebra our terms around so we can combine our like terms. So the time of the rabbit is 15. So if the time of the rabbit is 15 and the time of the rabbit is equal to the time of the turtle, well then the time of the turtle is also 15. Okay, see how that worked? All right, we're going to do another one off to the right here. And I'm going to have to erase this off because I didn't leave myself in. Well, there we go. I'll just, yeah, let me just erase this off. You'll have it in your notes still, so you're good. Whoops. Let me just put a big line down here. Okay, so example 2. See if I can get this where it's... Okay, I'll try it this way. See if this will work out for me. All right, so example 2, you're going to title this one, this is the freight train. And the express train. Okay, now here's the information we're told. First of all, we're going to solve for the rate of the freight train and the rate of the express train. And I'm assuming they're going to be two different numbers because you think of a freight train and an express train. Express train is going to go fast. Freight train is going to go a little bit slower. Okay, so we know our rates are going to be different. So here's what's given to us. So we have the rate of the freight times the time of the freight. That always equals the distance, doesn't it? Is equal to and actually, let's see. Okay, so the distances are the same. They're traveling the same distance. So they have, because remember, this rate times time is always distance, right? So what they're saying, their rate and their time may be different, but the distance is the same. Okay, so that's why it's set equal, because the distance is the same. Okay, so let's keep going. Also, we're told that the time of the freight is equal to 16. The time of the express is equal to 12. And finally, the rate of the express is equal to the rate of the freight plus 15. All right, let's fill in our parts here. We're going to use, what are we solving for? Oh, we need to put up here a little note. I'm going to put it right up here. Solve for, and you can do the same thing so you know what you're solving for. The rate of the freight and the rate of the express train. Okay, so we're looking for both of those. Now, they're not going to be the same, so we may have to do two different calculations to figure each one of those out. So let's go ahead and start with our original equation here. We have RF TF equals RE TE. We're going to fill some things in here. So RF is 16. I'm sorry, TF is 16. So we'll leave RF as is, and that'll be the first rate we solve for. Times 16 equals, and what is the rate of the express? Right over here, up to the, underlined up here, double underlined. So the rate of the express, I'm going to fill in here, is RF plus 15. I'm going to put that in parentheses. And the time of the express is right here. I'll triple underline that one, is 12. Okay, so now I only see I have one variable in here, R sub F, and that's perfect because that's what I wanted to do. So let's do the math on this. I'm going to switch that around. We have to distribute here, so I'm going to have 12 R sub F plus 60. I'm sorry, 12, no, not 12 times 5, 12 times 15. 180. All right, we'll subtract this 12 from both sides. Divide by 4. We're well on our way to figure out the rate of the freight train is equal to 45. Now, I can take this and find in my 4, in one of these 4 up here, I'm going to use one of those to substitute in this 45. So, where do you see an equation where you have R sub F in it? Well, we see it in the first one, but we don't want to redo that one. We've already used it. But we can choose to use this one on the end. R sub E equals R sub F plus 15. And I can take this R sub F that we solved for right over here for 45 and plug that in. And that's going to tell me the rate of the express train. So the rate of the express train then is 60. So there's your answer. You saw for the rate of both of those trains, 45 and 60. Okay, that's it for your notes. Now what I want you to do is open up in your books to page 325. Page 325. And you're going to do A and B in those little squares there. I'm going to continue on right here, right now, but you're going to pause the video and try them, and then you can come back and check your answers. If you got the right answer, you don't have to watch me work through those. If you made a mistake and your answer's not right, then you might want to watch through the problem. So go ahead and pause and work on your A and B and come back and check those. Okay, so letter A, what we are told, we have some given information here. The given information is that the rate of A times the time of A plus the rate of P times the time of P is equal to 460. And we are also told, and if you look up here, I'll go ahead and write them in here. RP is equal to 50. TP is equal to 4. And TA is equal to 2. And we have to find r sub a. Okay, so that's what we're going to work through here. So I'm just going to plug in my values. I'm going to take this first equation here, RATA plus RPTP, and we're going to plug in our values. So I'm not going to rewrite that. I'm just going to use what I have written here. So I'm looking for RA. So RA is going to stay all by as it is. TA is 2. RP is 50. TP is 4. Equals 460. So now let's just do the math on this. 2RA plus 200 equals 460. We'll subtract 200 from both sides. Divide by 2. And R sub A is going to equal 130. That's the answer to letter A. Letter B, we have RT, T sub T plus 200 equals R sub R times T sub R. We also have, I didn't finish that, did I? Yes, I did, okay. Then we have, the next thing, let me see here, is R sub T is 10. We also have R sub R is 15. We have T sub R equals T sub T plus 10. And we are to find T sub R and T sub T. Okay, so we're looking for two values here. All right, so let's start out by taking the original equation here and plugging in some values. So we see that R sub T is 10. T sub T is what we'll solve for here, plus 200. We see that R sub R is 15, and T sub R is T sub T plus 10. Do you all see that right over here? I want to make sure you see that. Let me grab yellow here. This T sub R is T sub T plus 10. Why? Because look at this one over here. T sub R is T sub T plus 10. So I'm substituting that value in for T sub R. Now let's just do some math here. I'm going to do some distributing on this side. We'll just rewrite what's over here. And then we're going to do some moving around. I'll go ahead and move this to the other side so I don't end up with a negative variable, which wouldn't really matter. It's okay if we did, but okay. And in that step, guys, I'm going to go ahead and do this part as well. We're going to do that all in one step. Okay, so what am I left with here? I have 50 equals 5 times T sub T. We're going to divide by 5. And T sub T is equal to 10. Okay, so I have solved for T sub T. Now I need to solve for T sub R. So we go back up here and we find an equation that we can use. And notice the one that I happen to have to highlight it here in yellow. We're just going to use that. T sub R is the other variable that we have to solve for. So we'll go ahead and plug in T sub T for that one and solve for T sub R. And what do we get? T sub R is equal to 20. Okay, and that's how you do those problems. Go ahead and work out the rest of the lesson and have fun with it, and we'll see you later. Thanks for watching.